Here I will explain, determine the field due to a straight current carrying filamentary conductor of finite length AB. This one is AB. Consider a conductor of finite length along z-axis. Finite length of the conductor along z-axis. The conductor is along z-axis with its ends, that means upper and lower ends, respectively, subtending angles alpha 2 and alpha 1. Lower end subtending angle alpha 1 to the point P, and upper end subtending at angle alpha 2 shown in figure. Most important point is consider a conductor finite length. Finite length is from A to B. This one is A, this one is B. Consider a conductor of finite length AB along z-axis. This AB, this one A and B is along z-axis, finite length. It carries a direct current I. 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 The perpendicular distance of point P, this is the point P, from z-axis is rho. The perpendicular distance of point P from z-axis is rho. This is the rho. Find out the magnetic field intensity H at the point P due to current carrying filamentary conductor of finite length AB. Find out the magnetic field intensity at the point P. Here. Next one. The conductor is placed such that its one end is at A, another end is at B, making an angles alpha 1 and alpha 2 shown in figure. The conductor is placed such that its one end is at, that means Z is equal to A, and other end at Z is equal to B, making an angles alpha 1 and alpha 2, making angles alpha 1 and alpha 2 shown in figure. This is the description of this current carrying conductor placed on the z-axis with finite length AB, making an angles alpha 2 and alpha 1 shown in figure. This P find out the magnetic field intensity H at a point P due to this current carrying conductor of finite length AB. Of finite length AB. The conductor carries a current I shown in figure. According to Bevart's law, according to Bevart's law, DH is equal to DH formula is I dl bar into R vector by 4 pi modulus of R cube. This one is the distance. dl is the current element. dl is the current element. Choose between these 2 points A and B. The current element making an angle alpha with this point P here shown in figure. Ends of the conductor making an angles alpha 1 and alpha 2. The current element dl making an angle alpha shown in this figure. This is the R is the consider vector form. Find out the R cap. Find out the R cap. This is the point P at which we need to calculate magnetic field intensity H. This is the rho. Unit vector is a rho along this rho. This conductor is placed along the z-axis at ends, two ends A and B. Here, the current carrying conductor is placed along the z-axis. The current is high. In this direction, Z into AZ bar or Z into AZ bar. In this direction, Z into minus Z AZ bar. This one is R. This one is R dash vector. Find out this vector. Find out this vector. Here, consider this direction, that is minus Z, AZ. Therefore, according to vector addition, R dash is equal to rho A rho minus Z AZ bar. Z AZ bar minus Z AZ bar. Here, mod R is equal to square root of rho square plus Z square. Mod R whole cube is equal to square root of rho square plus Z square whole cube. That is equal to rho square plus Z square. Root means 1 by 2 and whole cube. That is equal to rho square plus Z square whole power 3 by 2. That is mod R whole cube. Now coming to DL. Differential length in case of Cartesian coordinate system is DL bar is equal to dr air bar r d phi a phi plus dz az. The differential current element length, the DL, this one is DL, capital L. DL is along z-axis. Therefore, the remaining terms are 0 here, 0 plus 0. dz Az. dl bar is equal to dz az bar. Find out cross product in that Bevet-Savart equation dl bar cross r bar. dl cross r bar. dl bar is az az bar into dz cross r is equal to rho arrow bar minus z az bar. Rho arrow bar minus z az bar. Find out this one by using this AR A5 AZ. For this one AZ component is there, that is 0 0 dz. For this one rho 0 minus z. Therefore that is equal to here AR into 0 0 minus A5 0 into minus z 0 minus rho into dz. For az into 0 into 0 0, that is 0. Finally rho dz a5. Rho dz a5 is the substitute these values dl bar cross r bar. Therefore dh is equal to I into dl bar cross r bar by 4 pi mod r whole cube. I into dl bar cross r bar is this one is dl bar cross r bar is equal to rho dz a5 bar by 4 pi into mod r cube value is rho square plus z square whole power 3 by 2. Rho square plus z square whole power 3 by 2. Whole power 3 by 2. This is the now find out total h. Total h is due to two ends A to B is along z axis. Not dh is equal to I rho a5 dz by 4 pi rho square plus z square 3 by 2. Find out h. H is equal to integral of z limits. Z limits are from A to B. A to B because here z is there. I rho a5 I rho a5 dz by 4 pi rho square plus z square whole power 3 by 2. Whole power 3 by 2. Let z is equal to rho cot alpha because making an angles of alpha shown in figure. This one is rho. dz is equal to rho cot alpha is minus cosecant square alpha d alpha. For z is equal to a, lower limit a rho cot alpha. Therefore, cot alpha 1 for z is equal to a, making an angle of alpha 1. Here shown in figure, this one is alpha 1 for a, point A, lower end point A. Alpha cot alpha 1 is equal to a by rho. Therefore, alpha 1 is equal to cot inverse a by rho. This one is a lower limit. Upper limit is equal to b is equal to rho cot alpha 2. Therefore, alpha 2 is equal to cot inverse b by rho. Therefore, h is equal to the limits alpha 1 and alpha 2. I rho by 4 pi. Dz is equal to minus rho cosecant square alpha d alpha. Dz is equal to minus rho cosecant square alpha d alpha. Cosecant square alpha d alpha into a5 by rho square. Here rho square z is equal to rho cot alpha. That is z square is equal to rho square cot square alpha. Rho square cot square alpha. That is equal to I by 4 pi a5 alpha 1 alpha 2 minus rho into rho square minus rho square cosecant square alpha d alpha by, here some 3 by 2 is there. Some 3 by 2 is there. Rho square is common term. Rho square into 3 by 2. 1 plus cot square alpha, that is equal to I a5 bar by 4 pi alpha 1 alpha 2 minus rho square cot square alpha d alpha. C1 is not cot cosecant square alpha here. Cosecant square alpha by rho cube. 1 plus cot square alpha is cosecant square alpha into 3 by 2. Therefore, rho cancel. Rho square by rho cube is 1 by rho. I into a5 or 4 pi rho alpha 1 alpha 2 minus 1 by cosecant alpha d alpha. Cosecant alpha d alpha, that is equal to I by a5 bar 4 pi rho minus 1 by cosecant alpha is minus sin alpha d alpha, that is equal to I a5 bar by 4 pi rho. Integral of sin alpha is minus cos alpha. Cos alpha minus minus cancel. Therefore, cos alpha 1 alpha 2, that is equal to I A 5 bar by 4 pi rho cos alpha 2 minus cos alpha 1. Cos alpha 2 minus cos alpha 1. Conductor is semi-infinite. Suppose the conductor is semi-infinite means A is conductor is semi-infinite. Conductor is semi-infinite. That is A is equal to 0, 0, 0. B is infinity. Semi-infinite. The figure is like that here. This one is P H. Semi-infinite means here draw this one. Zero, zero, zero. Extended the point A is at 0, 0. Point B is extended to infinity. This one is the P point here. H. This one is rho. Here, this one is making an angle alpha. Alpha 1 here, alpha 2. From this geometry, alpha 1 is equal to 90 degrees. Alpha 1 is equal to 90 degrees. Z tends to 0. Z is at 0. Alpha 2 is equal to 0 degrees. Z tends to infinity. Z tends to infinity. Alpha 1 is equal to 90 degrees. Substitute these angles for conductor is semi-infinite. Therefore, H is equal to I 4 pi rho A5 I by 4 pi rho A5 cos alpha 2. Alpha 2 is 0 degrees. Cos 0 minus cos pi by 2. Cos 0 is 1 minus 0. Therefore, I A 5 by 4 pi rho. I A pi by. Suppose conductor is infinite length. Conductor is infinite length placed along z-axis. That means here this one is conductor, infinite length here, extended here, and here extended. Here A is equal to A 0, 0, infinity. B is here 0, 0, infinity. Here minus infinity. Minus infinity. Here the point P is there, perpendicular to that conductor. Here, here, and here. This one is alpha 2. This one is alpha 1. Alpha 1 is 180 degrees because the starting point here. Alpha 2 is 0 degrees. Alpha 2 is 0 degrees. Therefore, find out H due to that infinite length. The conductor length is infinite. I by 4 pi rho cos alpha 2 minus the cos alpha 1 into A5 here. A phi is also important here. A phi. I by 4 pi rho cos alpha to cos 0 minus cos alpha 180 degrees. That is A phi. I by 4 pi to 0 cos 0 minus cos 90 plus 90. A phi minus sin. I by 4 pi rho cos, this one is cos 0 minus into minus plus sin 90 A phi. That is equal to I by 4 pi rho cos 0 1 plus sin 0 is 1 A phi. I by 4 pi rho 2 into A phi. Therefore, 2 times here. Therefore, electric field intensity, not electric field, magnetic field intensity H bar is equal to I by 2 pi rho A phi. I by I phi 2 pi rho A phi. This is the magnetic field intensity, amperes per meter. Magnetic flux density B is equal to mu naught into H, mu into H here. H is I pi 2 pi rho A phi, I pi 2 pi rho A phi. Weber per meter square. Weber per meter square.